Welcome back. We are in the next lecture in power electronics. So in this lecture, we are going to focus on gate turn off thyristor. Let us see the outline. So we are going to discuss first on the introduction of GTO and what is the motivation behind the use of GTO as a powerful thyristor device. The basic structure and construction of GTO we will discuss. What are the current voltage characteristic of GTO, the operating principle, the switching characteristic, the ratings and the specifications, and we will compare it with the other semiconductor devices, some of the protection methods of GTO and the snubbers circuit, advantages and applications, and conclusions. So let us review the conventional thyristor limitations. So we were discussing that basically the thyristors are excellent power semiconductor switches having the high voltage and current rating. To turn on the thyristor, we apply the positive gate current with the gate current value greater than 0 between the gate and the cathode. Once the thyristor is turned on, it will remain in the conducting stage until the anode current drops below the holding current. Now there are two different methods of turning off the thyristor. One is the natural commutation and another one is the forced commutation. The natural commutation principle lies in having the AC supply which naturally drives the current to 0 because it will be going from positive to negative. And in the forced commutation, we will be requiring external circuit in the form of LC circuit that will force the current to 0. So the critical limitation of this thyristor is that it cannot turn off using the gate signal. So gate signal is only used to turn on the thyristor. But whenever we need to turn off the thyristor, the gate has no function. And when we use the forced commutation circuit in the form of LC circuit, they are basically bulky, complex and expensive. So this is the limitation of the conventional thyristor. What is a GTO? GTO is basically gate turn off thyristor. It is one of the modified thyristor that can be used to turn off the thyristor by applying negative gate current. The turn on can be done using the positive gate current where the gate current is greater than 0 and this is similar to the conventional thyristor. However, to turn off the thyristor in the GTO, we can apply the negative gate current. So the gate current will be less than 0 for sufficient magnitude. Self-commutating capability eliminates the need for external commutation circuit. So this is the advantage of GTO. We do not require external commutation circuit. Some of the key applications of GTO are used in the UPS system for the DC to AC inverters. We use in DC choppers for motor drives, variable frequency drives and high power switching applications. The GTO structure and construction. In the GTO, we have basically the 4 layer of semiconductor in the form of PNPN semiconductor device. The 3 terminals that we have is basically the anode, the cathode and the gate. So here we can see the cross-sectional structure of GTO. So anode we have and then cathode and the gate is used to turn on or turn off the thyristor depending upon its signal. So basically it forms 4 different layers in the form of PNPN. So we can see here how these layers are formed in the GTO as a semiconductor device forming the 4 different layers. The structural modifications compared to the conventional thyristor is that it is highly interheated. So you have the gate cathode structure. The anode is basically short, so N plus region will penetrate in the P-type anode layer. And the reduced P1 layer thickness makes the GTO to have the better turn-off capability. There is a shorter carrier lifetime in drift region around 1 microsecond to 10 microsecond. So the advantage of GTO over conventional thyristor lies in its capability to turn off the thyristor with the gate signal. Similar to thyristor, in GTO also is represented using 2 transistor model. So the 2 transistor equivalent circuit will have one transistor in the form of PNP and another one is in the form of NPN. So these 2 thyristors T1 and T2 form the 2 transistor model. So they are connected in the common base connection to give the regenerative feedback loop. So here we have thyristor T1 which is in the form of PNP transistor and another one is the T2 which is in the form of NPN, and they are connected with the common base. So the base is common and we get the regenerative feedback. So the current gain of these two transistors are represented as alpha 1 and alpha 2, and the circuit symbol, if we see for the GTO, it is similar to thyristor. However, there is a small difference where the two-way arrow is shown on the gate, which is basically indicating the bidirectional nature of the current flow. This distinguishes the GTO from the conventional thyristor. So we can represent the GTO similar to the thyristor with a small difference in the gate signal. So in the gate, we can have two different arrows, or we have one arrow with a small line. So this difference the thyristor from the GTO. When we talk about the VI characteristic of GTO, in the forward characteristic, it is similar shape to conventional thyristor, but with higher switching current. So this is the static VI characteristic of GTO, similar to the normal thyristor, and it will have higher switching current. In the forward, breakover voltage is achieved using the voltage around 200 to 8000 volt. Other characteristic of the latching current and holding current, with the latching current lies between 2 ampere to 10 ampere, whereas the holding current will lie between 200 milliampere to 500 milliampere. So this definition of latching and holding we have discussed in detail in the thyristors. Higher on-state voltage drop usually lies between 2 volt to 4 volt. Now, what is the reverse characteristic that we have in GTO? It has the poor reverse blocking capability. The reverse breakdown voltage lies between 20 volt to 30 volt, and due to anode short structure, it is having heavy doping, and the consequence is that it requires anti-parallel diode for AC applications. So wherever we need to have the GTO for AC applications, we will require one more diode in anti-parallel. In the forward blocking mode of the characteristic, the operating conditions where the anode to cathode voltage is less than the breakover voltage and the gate current is 0. The mathematical analysis, if we do, both transistors will operate with small current gain. So the current gain alpha 1 and alpha 2 for both the transistors will be very less than 1, and the condition for blocking is basically when the alpha 1 plus alpha 2 is less than 1. Now the equation of anode current that we can get from the two transistor model depends upon the reverse saturation current, which is IC01 and IC02, and it will be having the current in the junction J1 and J3. The gate current IG is 0 in case of the blocking mode, and here you have the anode current, which is lies for the current gain expression alpha 1 and alpha 2. So since alpha 1 plus alpha 2 is less than 1, the denominator is positive, and we can say that IA remains small in the GTO. So GTO will block the forward voltage with only small leakage current. So small leakage current will flow, and the GTO will be blocking the forward voltage. Now let us see the turn on process. So turn on mechanism goes like this. When you apply the positive gate current, so the gate current has to be more than the trigger current. The gate current will increase the base current of the transistor T2. Transistor T2 will start conducting, and it will increase the collector current. Then the collector current of transistor T2 will become the base current of transistor T1, and this transistor T1 will start conducting, providing the base current of transistor T2. So this is basically the regenerative action where both the transistors saturate rapidly. The mathematical condition for the GTO to turn on, having the current gain alpha 1 plus alpha 2 is equal to 1, and when this condition is met, we can say that alpha of the two transistors, alpha 1 plus alpha 2 being equal to 1, we can have the anode current tending to infinity, but it will be limited by some external circuit resistance. Gate current requirement, we have the minimum gate current. So the trigger gate current is around the approximate value of 0.1 ampere to 1 ampere, where the trigger voltage that we required is around 2 volt to 5 volt. So these values has to be met to turn on the GTO. When we talk about the turn off mechanism, which is the main advantage of using the GTO, we apply the negative gate voltage less than 0, and this negative gate current will extract the holes in the P1 base region. The base current of transistor T2 will become negative, due to which the transistor T2 will exit saturation and the current gain will drop. junction J2 become reverse biased and the electron injection will be there from the cathode will stop. The stored charge will recombine and cause the tail current. So GTO regain forward blocking capability. Turn off condition will be achieved when the transistor T2 will exit the saturation when the base current of transistor T2 is less than the ratio of the collector current by the beta value for the transistor T2. Turn off gain beta is basically the ratio which we get from the anode current by the gate current. So this can be obtained using the current gain values alpha for the two transistors alpha 1 and alpha 2 using this expression. Typically the value of beta of lies between 3 to 10. Turn on characteristic, we require the gate current requirement. So the peak gate current should be around 10% to 50% of the anode current, and the rate of rise of the gate current should be greater than 10 ampere per microsecond. The pulse width of the signal should be around 10 microsecond to 50 microsecond, and there is something which is known as back porch current, which is a small current which is maintained during the on state of this GTO. The delay time of the pulse is basically 0.5 microsecond to 2 microsecond. The rise time lies between 1 microsecond to 5 microsecond, and the total turn on time, which is the summation of delay time plus rise time. Critical design consideration, we required all cathode segment must be turned on simultaneously, and there is high ratio of di by dt in the gate which will prevent the current crowding. Low gate circuit inductance is very essential. Now if we see the turn off characteristic, the gate current, so the peak reverse current of the gate is the ratio of the anode current by beta times the off value, and the rate of fall of the gate current should be greater than 100 ampere per microsecond. Gate resistance should be less than 1 ohm for having the fast turn off of the GTO. Turn off timing, if you see the storage time, it is having the value around 5 microsecond to 50 microsecond, the fall time 5 microsecond to 20 microsecond, and the tail time we have 50 microsecond to 500 microsecond. So the total off time of the GTO is the summation of the storage time, fall time, and the tail time. So these turn off waveform which shows the storage, fall, and tail times are basically shown by this characteristic where the gate current is applied in the positive region to turn on the thyristor. We can see the anode current will increase, become constant, and then it will decrease. The voltage across anode to cathode voltage will be constant initially, then it will increase because of dV by dt, and the voltage across the gate to cathode will become constant, then it will decrease, become constant, and then it will increase and saturate. So these are the typical characteristic of the GTO during the storage, fall, and the tail time. Some of the key GTO ratings, if we talk about the voltage rating, current rating, switching parameters, and thermal rating. So these ratings are very important in the operation of GTO. So we say the voltage in the DRM, which is the peak repetitive forward blocking voltage, is around 1200 volt to 6000 volt. The peak repetitive reverse voltage lies between 20 volt to 30 volt. Peak on-state voltage is 2 volt to 4 volt. So these are the voltage ratings. Current ratings, similarly, we have the RMS on-state current 50 ampere to 6000 ampere. Holding current, we have 200 milliampere to 500 milliampere, and latching current 2 ampere to 10 ampere. When we talk about the switching parameters, the turn off gain beta lies between 3 to 10, and maximum switching frequency is up to 10 kilohertz. Di by dt capability, we have 100 ampere per microsecond to 1000 ampere per microsecond. The thermal rating of the GTO, where the junction temperature may reach up to 125 degrees centigrade. The thermal resistance is 0.1 Kelvin per watt to 1 Kelvin per watt, and power dissipation is critical for high frequency operation. So the GTO has to be operated using these particular ratings, otherwise the GTO may not function well. Now when we compare the GTO with the conventional thyristor, so the main advantage of GTO is that it can have self turn-off capability, whereas conventional thyristor require external commutation. The latching current is higher in GTO but lower in the conventional thyristor. The higher on-state drop is there in GTO, which is lower in case of thyristor. complex gate drive circuit in the GTO because the gate is the one which is turning off the thyristor of the GTO, but the simple gate drive circuit is there in the conventional thyristor. It will require external commutation. Poor reverse blocking capability, it has good reverse blocking. GTO will have faster switching up to 10 kilohertz, whereas conventional thyristor will have slower switching up to 1 kilohertz. The GTO is having compact circuit size, whereas conventional thyristors are bulky because of the commutation circuit. The gate drive losses are higher in GTO but lower in case of conventional thyristor. GTO again required some of the protection requirement due to high dV by dt and high di by dt, which is because of during the turn off and turn on characteristic of the GTO, which can damage the GTO. So we need some form of protection of the GTO from over voltage in the gate cathode junction. So the protection circuit which we know is very famous is basically the snubbers circuit. So it will turn off the GTO in the using the RC circuit across the anode to cathode. It will limit the dV by dt during the turn off. So the typical values of these resistor lies between 10 ohms to 100 ohms and capacitor between 0.1 microfarad to 10 microfarad. The turn on snubber, we will be requiring a series inductor which will be limiting the di by dt during the turn on. The gate protection can be done using the linear diodes across the gate to cathode, and overcurrent protection is also required using the fast acting fuses. Thermal management has to be done where the adequate heat sinking is required due to higher conducting losses, and the junction temperature monitoring is also very essential in case of GTO when it is operating at a very high current. Some of the advantages and disadvantages of GTO we have that GTO can be self turn on, it eliminates the commutation circuit, it is faster switching than the conventional thyristors, it reduces the electromagnetic interference, simplified control circuit and better dynamic response. Whereas the disadvantage is that it has a complex drive circuit, it has a higher gate drive power, poor reverse blocking, higher conductive losses, limited switching frequency, require anti-parallel diode and most expensive than the SCRs. When we talk about the trade-off, it has the higher complexity and cost, but it is having the improved performance and circuit simplification. So GTO is generally preferred because it has the self turn-off capability. However, the circuit is little bit complex. Some of the application of GTO in detail we can say for the major application as variable speed drive like in DC choppers and AC voltage inverters, high frequency industrial drives, power static applications we be having where we are using static VAR compensation, high voltage DC transmission, power quality improvement system. We use in railways as a traction system using the railway locomotive drives in the electric vehicle propulsion. Industrial applications when we talk about, then we use in UPS, induction heating and welding equipment. So GTO has very wide major applications in different areas of power electronic applications. So let us summarize what we discussed. So the key concept that we covered is basically GTO will provide the controllable turn-off capability through the negative gate current. There is structural modifications which enable the turn off. So anode is basically short and there is interdigitated structure. The turn off beta, which is the ratio of anode current by the gate current, is typically in the value of 3 to 10, and the trade-off is basically better controllability versus higher complexity and the losses. So it requires protection circuit and the anti-parallel diode. So anti-parallel diode in the case of AC. Design consideration when we talk about, then the gate drive circuit is critical, snubber circuits are mandatory, thermal management is important, and consider the switching frequency limitations. So these are certain design consideration. So this complete our discussion on the GTO as one of the thyristor families. So we have basically covered by now all the thyristor family, and in the next lecture we will begin with the controlled rectifiers, first the single phase and then move to 3 phase. Thank you for now.